Resistors, capacitors, and inductors are essential components in an electronic circuit. These are passive components. So, what is a passive component? Passive components are responsible for absorbing energy from the circuit, and active components delivers power or energy to the circuit. Let's delve deep into resistors. What is a resistor? Resistors are two-terminal passive components that introduces an electrical resistance in a circuit. These are used to restrict current flow. So, how do they work? You may have heard about conductors. Conductors have many free electrons in them. When a voltage is applied, electrons flow through them effortlessly and constitutes electric current. On the other hand, resistors do not possess as many free electrons as conductors, and the electrons they have find it difficult to pass through them. In a resisting material, as electrons move, they collide with the atoms within the material and loses some of their kinetic energy. This energy causes vibration of the atoms and is dissipated as heat. This process slows down the electrons. This restricts current flow. Ohm's law. Ohm's law is a fundamental relationship between voltage, current, and resistance. Ohm's law is defined as V equals IR. For a given resistance, if you increase the voltage, the current increases. Voltage is directly proportional to current. Ohm is the unit of resistance. The resistance value is usually denoted as this. The value after the plus minus sign is known as tolerance. No resistor is perfect. Tolerance is the maximum permissible variation of the resistance from the stated value. Common tolerances are 1%, 5%, and 10%. Resistors usually have some power rating in it. It indicates the maximum power it can dissipate without being damaged. There are many types of resistors. Fixed resistors having constant resistance value. Variable resistors or potentiometers. Their resistance can be changed. Special purpose resistors. Resistance value varying upon some external factors such as voltage, light, temperature, etc. Why are resistors so important? To protect sensitive components from excessive current, heat generation, voltage division. Resistors allow us to proportionally reduce a large voltage into smaller usable voltage. You may ask, why do we need resistors for voltage division? Can't we just use the correct voltage source? For simple circuits, we can use the correct voltage source instead of wasting a lot of energy as heat through the resistors. But what about complex circuits containing multiple components that require different voltage values to operate? It is inefficient, impractical, and expensive to use individual sources for each. Practically, we use a main source with a high voltage and resistors step down the voltage for each component. Next one is capacitor. A capacitor is a passive electronic component that stores energy in an electric field. It is like a temporary battery that stores energy electrostatically, unlike chemically in batteries. A simple capacitor consists of two plates separated by a dielectric medium. Dielectrics are insulating material that can be polarized when applied with an electric field. When you connect a capacitor to a voltage source, electrons flow onto the plate of the capacitor and makes it negatively charged, and simultaneously electrons are pulled from the other plate and becomes positively charged. This separation of charges creates an electric field between the plates, and this is where the energy is stored. If you disconnect the source and connect a path between the plates, electrons from the negative plate will flow to the positive plate, releasing the stored energy. Capacitance depends upon surface area of the plates, distance between the plates, and the type of dielectric used. What are capacitors used for? Filtering. It is used for turning pulsating DC into a more stable output. Timing circuits combined with resistors to create time delays in blinker circuits or timers. Energy storage, frequency filtering. There are different types of capacitors such as electrolytic, ceramic, mica, supercapacitors, variable capacitors, etc. And finally, inductors. Inductor is a passive electronic component that stores energy in the form of a magnetic field. It is typically a coil of wire. Whenever current flows through the coil, a magnetic field is generated around it. If the current changes, magnetic field also changes, and the changing magnetic field induces an EMF. This EMF is in such a direction so that it opposes the change in current. When you start a current through an inductor, energy is drawn from the source and it is used to build up the magnetic field. Thus, energy is stored in the magnetic field itself. When the current stops suddenly, the collapsing magnetic field induces a current in the same direction to keep the current flowing. This is how it releases the energy stored. An inductor is a coil of conducting wire wound around a core. But why does it behave differently than just a straight conductor? A straight conductor does produce a magnetic field when current flows through them, but this field is weak and spreads out. It is not enough to store significant amount of energy. Coiling the wire increases the magnetic field and confines it. Here are the main types of inductors: air core inductor, iron core inductor, choke, variable inductor, and toroid inductor.